Okay, so hi everyone. This is Norma. I'm from the EX team. Thank you for joining us. We're really excited for today's presentation. Today's presenter is Steven Ibach, that looks on my left side on my screen. So he will be discussing about secure coding. A little bit about him. Steven started at Nextiva in April 2012 and have had previous positions in tech support, T2, QA, and DevOps over the years as the company has grown. So he has gained a firm understanding of Nextiva's software stack and the challenges we face. Outside of work, he enjoys reverse engineering hardware and websites. So he's always on Slack. You can just ping him at any time. Before we get started, I just want to remind you that if you're interested in presenting, just reach out to the EX team, either Terry, Ruth, Enid, or I, and we will help you to get it arranged. We really love like these presentations. Very much. So also we will have a trivia at the end of today's session. So stick around for about like 5 minutes after the presentation, and it will be dropping the Kahoot link, and we'll be having some fun. Of course, we will have some Uber Eats vouchers for the winners. So yay. Okay, that's all I've got. So take it away, Steven. Thank you for doing this.
Okay, awesome. Thanks. So this is going to be an introduction to secure coding practices and some of the things that stand out to me as important at Nextiva compared to just like whatever you might see online. So I'm going to go through what OWASP is and how useful they are in understanding all of these problems and perhaps even discovering ones that we weren't aware of. And a few different categories from there. I'm going to go into more detail about security misconfiguration in setting up our applications. And I have some examples for cross-site scripting and indirect object references and a few other things. So one quick note on compliance, since there's a lot of overlap here. We have part of security is also making sure that we're like compliant with licenses in our applications, making sure that all that stuff is right. So I'm just going to throw this up there and just leave it at that.
Nice. Sorry, Steven. Just like a quick note. If anyone has questions, you can just drop those on the chat. You don't have to wait till the end for questions. You can just put it there.
Yep, that sounds good. I don't think I can see the chat, so I'm gonna.
No, I will be taking care of that. Don't worry.
Okay, sounds good. So OWASP is a foundation that does open source web application. Well, it's the Open Web Application Security Project. It's a nonprofit that works together to try to discover all of the problems that companies are facing and how to educate people on them. And they come up with a whole bunch of different, they have a bunch of different projects that are underneath their umbrella. The big one, I think, to us is the OWASP Top 10, which they update every few years. And it's the top 10 vulnerabilities that they see in websites that people should pay attention to and address. So, well, here's a description from their website. So the number one to them is injection attacks. So that would be SQL injection or command line injection, a whole bunch of different things. Not, thankfully for us, most of the ones that they consider injection attacks don't apply to us because we use ORMs in most of our code, which should prevent most of the SQL injections. And because we use Java and some other stuff, we're not really vulnerable to OS injections. Well, we could be. I shouldn't say we aren't, but so far I haven't seen any. So that's their number one. Broken authentication is a super important one. where you can somehow manage to bypass authentication or get session keys that you shouldn't have. And this is sort of critical in all cloud applications. And I've seen way too many problems with this with our vendors. I don't know that I have any good examples for us here, but definitely with some of our vendors, I've managed to get long-living tokens to log me into things I shouldn't have access to. Sensitive data exposure is on there because it's just such a high risk for companies now, which means what they consider sensitive data exposure is financial information, healthcare information, PII that could lead to like credit card fraud or identity theft, things like that. So making sure that you have your data encrypted and that you have access controls put in place so that only people that are authorized should have access. Number 4 is XML external entities, which I find fascinating because, well, most of our apps don't use XML, so this doesn't really apply to us. But this would be specially crafting an XML file to, say, pull files from the file system on the remote server and then return them back to you. So if your XML parser supports those kinds of tags, then you can include files that are on the server that's receiving your XML file and then have them sent back to you somehow. I don't think we have to worry about that. I hope we don't, but it's good everything's moving to REST and JSON. Broken access control is number 5, and this one I think is critical to us because it relates to access controls not being implemented properly. So maybe I have to, say, log into an application, but if I change the username in the URL, I can access another user's documents or something like that. And this I've seen across the board in our applications, our vendors' applications. The fax portal is a great example of this across the board. Well, not anymore, but it was a year ago. Number 6 is security misconfiguration, which is a broad umbrella for pretty much knowing the tools that you have and then implementing them properly so that you, say, don't expose cookies the wrong way, or you want to make sure that your OS is hardened and that you have firewall set up, all of that kind of stuff. And making sure that your OS is up to date and everything is patched. Number 7 is cross-site scripting, which is also a huge problem, especially as we move more towards applications that depend on JavaScript for all of their functionality, and having websites that are dynamic and pull data from different places and take information in URLs and render them back to you on pages. And I definitely have some good examples of this in our applications right now that I found last night, or early this morning, I should say. So that's definitely a hot one for us. And number 8 is insecurity serialization. This I don't really have much experience with at Nextiva, so I'm going to leave that one alone, but I don't know that we do much deserialization of data. Well, yeah, I'll just leave that one for now. Number 9 is using components with known vulnerabilities, which seems related to the security misconfigurations and making sure packages are up to date. But I think they consider this so critical that they wanted to make sure it was on there very clearly, because it's difficult to keep packages up to date, and it's difficult to move from packages that are no longer supported to new different packages that might require rewriting large parts of your code base. We definitely have that problem in some of our applications. So the combination of, is everything patched and are all your dependencies up to date, and are your components actually safe? Are they still supported? And number 10 has to do with insufficient logging and monitoring, which is also a problem if you've ever tried to search our logs and figure out what's going on. We have that same problem about not either logging too much in some areas or not enough in others, so that we don't actually know what's happening. And I know we're making progress in that area, but obviously that requires a lot of work from other teams. I think the biggest thing to note in all of this is that you really need to understand the tools that we have and how they need to be configured. And of course, they're all really complicated, and so that's time consuming. And I mean, I don't expect anyone to really fully understand all of this, but I think this is the perfect example here.
Nice. Steven, we have some comments from John Coffey. He says that the number 9, using components with known vulnerabilities, is a huge one for us. And almost all of our apps have all vulnerable versions of components. We know this from Veracode scanning. So thank you, John, for adding these comments.
Yep, that's absolutely true. And we also have one of our crypto libraries that had a breaking change like 10 years ago in versioning, and we never upgraded because it would require rewriting a bunch of stuff. So we're using that old component because we can't upgrade without rewriting everything. So that's definitely fun. So I think security misconfiguration is a big one for us, because when most of this stuff was set up, or well, depending, we were a much smaller company with a lot fewer people doing things and a lot fewer people fully understanding what it is we're trying to set up. So I broke that down into a few different sections. OS issues don't necessarily apply to developers, but it does or can impact your application. So I wanted to go through those real quick. Using out-of-date operating systems or end-of-life operating systems is a big one, because it takes work to upgrade all of this and build new servers and stuff. Not applying patches. And these are all problems that we face here. So obviously this could get a lot broader. Patches not being applied in a timely manner, so we know that everything is up to date. The most critical systems would be our firewalls and web proxies, the things that are on the internet for a lot of that. Firewalls not being configured on hosts, and access controls not being implemented. So if we don't have these things right, if we're sharing logins to servers, then of course you have access to all the data the server has access to. So that's pretty important. Tomcat is a critical one, because we use Tomcat for all of our Java applications. So according to them, on their security considerations page, they say that Tomcat is reasonably secure for most use cases, which is just not true if you're going to put the application on the internet. I spent way too much time years ago rewriting all of our Tomcat configuration, and just most of their defaults don't make sense. So we have Tomcat Manager enabled, which we shouldn't if we're not using it. That can also, I'll get back to that one in a minute. Tomcat is by default configured to return exceptions and error messages to the user, so they see stack traces, which obviously you don't want to do because you don't want to disclose any more information than you have to. So we should be either handling all of the errors on the back end, or if there's something that we can't handle, we should be returning the error code, but not detailed description of what the error is that could describe the internal state of our system. More sensitive data exposure. We always change the host header, or well, not the host header. I should have put down which header was on here. The server header to say what the server is running. By default, I believe it's Tomcat and then the version of Tomcat. So if that information is on all of our websites, someone can say, hey, I know what they're running, and I can look up what exploits are available, and I can see if I can break into their system. So we want to minimize that as much as possible. So our web proxies and all of our Tomcat servers should or are configured to just say Nextiva web server, so that it's nice and generic and no one can figure out what it is from that at least. They don't configure cookies, to be served up properly. So they really expect you to do at least some work if you want to use HTTPS. And this is a big one that we still have a problem with, is that the applications that have different access requirements run on the same connector inside of Tomcat, which means they're exposed on the same port. So this is the same with Tomcat Manager as well, along with like ACE and Office Manager, which require different access controls. One of those should just be an internal application. So to bring all of that together, for Tomcat, there's an interesting path traversal vulnerability that they don't think is a problem, I guess. So this URL should be the URL to our Office Manager portal, where customers log in and view their website. But if you put the ... semicolon after that, it takes you to the root context of the application, which displays a bunch of information and would also let you get to the Tomcat Manager from here, which is another reason that we should have that disabled if we're not using it. Same with this. I pulled this last night, so this is all still running like this. Now, this by itself might not be a problem, and if Tomcat Manager is disabled, then this definitely is some information disclosure, but it gets more interesting when you realize you can access other applications running on the same host. So if we do something like this, we can see the broadband portal, which is the customer login to this application, which runs on a different domain, but is still accessible through here. This also works for ACE, which is why this is so critical for us outside of the Tomcat Manager, because ACE runs on this same server, and that needs to be internal only for a ton of reasons. We prevented access to that in our WAF immediately once we figured out this one, but this just shows that even if you think that everything is set up right, that in this case, Tomcat doesn't always agree with you on what are security vulnerabilities. So making sure that you isolate applications that need different access controls on different connectors ensures that this isn't possible, because your connector will only have your application on there. Spring Boot is another component we use, or framework, I guess, that is, I probably don't really know quite how to describe this, but it's on top of Tomcat. It runs along with Tomcat. And it has a bunch of actuators that let you introspect the running configuration as well as making changes to it, which is really cool. But if we run these actuators on the same endpoint as the application that we're serving, then we're going to have the same problem as I just showed with the Office Manager and employee portals, where someone can go to one of these services that's running in Spring Boot and then put in the ... semicolon / and then they can put in the path to the actuators and actually get data back. So we turned off most of the actuators in our applications that are exposed to the internet, but when this came up, here's a list of a few of the more critical ones that we had on some of the applications that would let either an authenticated user, that would be just anyone who can access the application, or in some cases an unauthenticated user, do thread dumps on the application, which would contain huge amounts of information, including passwords to just anything that was in memory we could get access to. Same with the HTTP traces, where you can get header data that contains authentication tokens. You can also enumerate all the pages in the application with the mappings and beans endpoints, and you can get environment variables and configuration properties, along with all the logging configuration. And you can adjust the logging configuration actually, so you could theoretically turn log level up to trace and then start pulling logs off the applications. So this is another fun one for sure. Docker is another tool that we're using more and more these days. And I just stole this from Docker's website about what a container is. But it's pretty much just an isolated environment that your code runs in that's a mixture of a bunch of different access controls that make sure that your code only has access to the part of the file system you've given it access to and only has permission to do certain things that you want it to be able to do. But all of that configuration is really difficult to set up. So you really need to understand what it is that you're doing and if you intended to give it the access that you gave it or not. So it just works something like this. This is also from that same Docker website where all of your apps are isolated from each other and shouldn't be able to access each other's data. There's a few security configurations or considerations that should be considered when using Docker or when looking at the apps that we're deploying in Docker. Docker's filled up a...
Sorry. We have a question from Miguel, but yeah, Miguel, the slides will be available on Confluence. And everyone, if you have any question, just drop it on the chat. Sorry, Steve.
Yep, no, I'll make the slides available. Docker is composed up of a bunch of different images that sort of stack on top of each other to build your application. So you really need to trust all of those images and where they come from to make sure that they don't have anything malicious in them, which can be confusing sometimes. You also want to make sure that Docker is configured to provide the least amount of access needed for your application to run. So if it doesn't need certain OS permissions, you don't want to give it to Docker. You also don't want to make sure you can't like log in to like SSH into the Docker container if you have no reason to do that. Just best practices to disable everything that you aren't using. One critical one is, did you define a user that the application will run as? If you don't define a user in Docker, it will run as root or whatever user the Docker daemon is running as, which is almost always root, which means that if you start up a container without defining a user, it will have full access to everything because it's running as the root user. So it bypasses almost all of the security controls and benefits that we would be getting from the application. This is a huge issue, at least as far as I've seen here, where we're building Docker files and not specifying users, so the processes are running as root, which means that they would have access to resources outside of the container. Not good.
Steven, have we had any issues using Docker so far for not following the recommendations that you said?
Yeah, so I was searching in Datadog, and it appears that most of our Docker containers are running as the root user. So that's not good.
Okay.
That means that it's not really enforcing the security controls that we expect from Docker.
Okay, thank you.
Pretty much to wrap all this up, you always want to try to use the right tools for the job, whatever that is. So if you, say in this example, don't need Kubernetes for your stuff to work, there is no point in trying to set up something more complicated than you need because you're going to end up with problems. Now, of course, we use Kubernetes here and we probably do need it to manage auto scaling and stuff, but yeah. Dependency management is another critical one for us. So I guess where all of the code in your application comes from, you really need to understand that and what that means. And this falls under multiple of the OWASP top 10 for issues. So in our Java applications, we use Maven to manage dependencies. But Maven does significantly more than that. It makes sure that it has a defined XML structure that handles the whole life cycle of the application. So part of that includes specifying other of these project object models to pull in to build your application. So it's extremely complicated, but also extremely powerful, which is another example of where we need to understand the application that we're using so that we make sure that it's configured properly. There's a large number of lifecycle phases, but here are some of the ones that we probably use in our applications. So like the build would, actually I don't have build on here. Build would build the application and build like the result object from that, and install would do the build lifecycle phase and then also install it to your local Maven repository. The site one builds the website that can be generated depending on if that's configured to show all of the, I guess it depends what you have in there. But one of the key things that we can put in there is third-party plugins into Maven can build and add to the site that gets built. So you can have a site, like a page on the site that's generated that shows all the dependencies in your application, along with all of the vulnerabilities there. That's using one of the OWASP plugins for checking dependencies. So as your application is built and then the site is built, all that can be checked automatically. We used to have that set up. I don't know if we do anymore, but Maven is a super cool tool that is, I think, far more powerful and complex than I've seen it used here. It also, probably should have included this on the previous page, you can also run scripts inside there. So as you're pulling in dependencies, those dependencies can run scripts on your computer, shell scripts or other scripting languages to do the building of the application. So you really need to trust where your code is coming from. So that's, so what dependencies are you pulling in? That's not something that's immediately apparent if you examine the POM file. It's going to tell you where some of the dependencies come from, but then they pull in more dependencies. So that's a little complicated. What licenses do your dependencies use? So we can get into huge trouble if we're using something that is, say, AGPL licensed, which means that we can't use it for commercial use in any way without paying someone some money somewhere to get a different license. Are you only using dependencies that the application uses? Are you pulling in dependencies that you may be used to use or don't need for whatever reason that could introduce vulnerabilities into your application, or I guess also licensing concerns? Do you trust the dependencies to run scripts in your environment as you do the build and install process? And are your dependencies up to date and without security issues? Maven has some ability to determine that, to figure out some of this. One of the more useful commands I've found is to be able to build a dependency tree. This will show you all of your applications and for all of the dependencies in your application, and then what dependencies they depend on. And it will list out all of the versions in a tree form on your command line, which is super useful if you can't figure out why the application isn't working, or if you need to know what's in your application to make sure that you don't have any problems. You can also generate an effective POM with a similar command, which should build all of this for you so that you can see in that one file what your application is actually doing after it pulls in all of the parent POM files. Maven also, actually, so for dependency management, we have some third-party tools to help with that. Now, these issues are going to be the same with like Python and JavaScript, but a little different. So like in Python, we need to make sure that we pin the versions that we're using when we build an application so that we know that we're getting the dependency that we expect. But that also means we need to make sure that those pinned versions are the up-to-date version that we've tested in our application. We have some third-party tools to help with this as well. So Veracode does dependency analysis in our applications along with the static and dynamic code analysis. So they can tell us licensing in the applications. They can also tell us if we're using a version that has vulnerabilities, which can be helpful. It's actually, for our Java applications, easier to use the OWASP dependency check plugin for Maven, which will be part of the, you can run a Maven command to do the dependency check. And so you're much more likely to get accurate results with this because it's going to be directly tied into the system that's building the code. Whereas Veracode, we have to upload a file and it has to sort of figure these things out, and it's not always perfect. But the dependency check plugin pulls all of the data from, and I forget where, but it contains all the CVE data and all the vulnerabilities for the applications and plugins. So it will check the versions of all your dependencies and then see if there are any vulnerabilities, and then it will categorize them into different categories of, this is a high vulnerability, and this one has a score of like 9.8, which would be critical, so that you can see what problems your application might have. Now we could also, with the dependency check plugin and Maven, we can say if your application has too many of this level of vulnerability, or has vulnerabilities above a certain level, you can actually prevent the application from being built. We can also send the dependency check data to SonarQube, which would show that same sort of data in there, along with the other features that Sonar provides, code quality and stuff like that. Moving on to having untrusted inputs in your application. This is a real critical one for us for everyone, because you need to validate what's being put into your site and what you're storing, so that at no point can anyone execute code anywhere in your system accidentally. It should only be, intentional, like what you expect to happen. So most of these things are things you don't expect to happen. Someone puts in something in your form that they shouldn't put in, and then it breaks your application or gives them access to your system. This would be the same sort of thing as a SQL injection, but in our case, most of it's going to be like cross-site scripting attacks and stuff. So to prevent that, we need to make sure that we do validation on all of the data that's put into our application to ensure that that data matches the format we expect in there. So if you're asking for someone's name, you want to make sure that it's not too many characters, whatever that is. In this case, it would probably be defined by our ORM and the database tables. But if it was some sort of free-form field, then that might be all right. You want to make sure that it doesn't contain special characters. If names shouldn't have quotation marks in it, then you shouldn't allow quotation marks in the name, just to prevent as much of this as possible. We also must validate. So all customer inputs need to be validated, and also data we pull in from third-party APIs. Depending on the vendors and the third parties, this could be more or less critical. So if some third party was compromised, what could they send us that we could end up executing? That would be the concern there. Now, this sounds like it's just a nightmare for making things work, because I know every time I go to a website and I fill in a form, it submits it to the server sends something back, and it's like, no, we don't like your email address because your domain starts with xn --, and apparently we don't know that's a valid domain. And that's the problem I've had, because that's what I get for choosing special domains. but we really need to make sure that we do client-side validation first. So you fill in the domain in that case, and if the domain doesn't match the regex that the server side would use to validate it, then it should tell you before it sends it to the server. Like with a lot of security stuff, it should simplify things rather than make them more complicated. So you should be doing, client-side validation so that the customer gets immediate feedback on what is valid and not valid. But then you do server-side validation to make sure nothing bad gets into your system. So along with that, we have cross-site scripting attacks, which allow remote code execution on the end user's browser or someone else's browser, depending on the type of attack. So there's reflected cross-site scripting attacks, which would be where you have like a URL that contains some field that you can fill in. And when you put JavaScript in there or an image tag that links to a file somewhere, that will actually be rendered back to you when you go to it. So you could send someone a link that will execute JavaScript on their computer. That would be compared to, say, a stored cross-site scripting attack where you fill out a field somewhere, and then that gets saved to the database. And then when someone else goes to that page, or you, or whoever, that gets executed and then sent back. That gets executed at that time when you're viewing it later. And then there's also the DOM XSS, which I don't fully understand. I guess I probably should read more on this, but it has to do with JavaScript frameworks and single-page applications that dynamically include data that comes from something that's in the scope of access to the user. I'm not entirely sure how that would apply to a lot of different things and how it is differentiated from other attacks, but so I don't have a good example of that one, I should say. So here's a really interesting example that you probably shouldn't do in ACE, but you definitely could. If you set the account name in ACE to this string here, this will result in the JavaScript being executed when you go to, when you look up the account, when you do a bunch of things. I've gotten into trouble with this one, actually, because not only when you search for this account in ACE, you'll get a pop-up like that, of course, when you do this. You get multiple pop-ups. So now when you search for this account in ACE, you get 2 pop-ups because that field is filled in twice on the page. And when you click on the account, you get 3 pop-ups on the account page that I'm showing here that you're editing because it runs 3 times, which is extra special. Now with this one, it will also actually execute in the partner portal if it's a channel account because the name is also shown there. And the same stored cross-site scripting attack works in the partner portal. So it's kind of good customers can't change their company names. That would be a problem for us. This one I found last night while looking for something else. In the NextOS call flows, you can define your name of a call flow to be this here. And this will, I can show you how this works a little more, but if you put this in for the name of your call flow, like this, it will work fine. You can save it. But then when you go to view your call flow diagrams, you get a pop-up, of course, because that's what's in the JavaScript. So when we send the data to the server on this request, it escapes the characters in the name field. But then when it's sent back from the database, those same things aren't escaped when they're displayed to us. So here's the section of code that gets populated on the page. And if you notice, the name field here for the diagram doesn't have the second quote character escaped, which means that I'm allowed to close the quotes inside the diagram. And then I close the the array and then the list so that it looks like so it doesn't cause the JavaScript to crash here. And then I put in my JavaScript function I want to execute. And then I just define a new object so that it doesn't have any parsing issues on this. And this definitely causes this pop-up to happen as of this morning at like 1 a.m. So that's fun. I'm sure this is an issue all over the place. And this isn't necessary. So this doesn't seem like a big issue, but it means that you could cause other things to happen. So you don't just get pop-ups, but you could say, name a call flow something, and then call into our support team and say, hey, I'm having trouble with my call flow. And then they log in and they look at it. And when the page loads, instead of having a pop-up come to them, you could have it open an iframe or redirect them to a URL in ACE that creates you an admin user, which you can totally do because I tested that yesterday. And that's also a problem with ACE where we allow GET requests to modify things. So usually you should only allow post requests to make changes to systems. That way you can't send someone a link and then they just view the link and it creates them a user or deletes their user or, suspends their payments forever or gives them money. All that stuff is probably possible if you knew how to craft the URLs. So don't do that. Another big issue that I've seen across the board and most recently in our fax platform is insecure direct object references. So that's where that's part of OWASP number 5, which is broken access control, where you have some either in the URL or as a parameter, you can specify some object, a user or a fax message or something like that. And then you can change that to be some other user or if it's like a unique identifier, you can either randomly generate unique identifiers and start looking for things, or you can do a huge number of different things depending on if you know what the identifier represents. You can start putting in other email addresses and see whose data you can access, things like that. So in the fax system, I really wish I had taken screenshots or videos of all this when we went through this, but I took this example from a bug crowd report that lets you delete another user's faxes. And it's pretty easy to execute. Log into the fax portal and send a fax with one account. And then find that fax and get the record ID. This makes it easier so that you can actually quickly prove that this is what's happening. Then log out of the first account, log into another account that's not related, and then send the message to delete the fax, but put in the record ID from your other account. And so this did allow you to delete faxes. This would also, there were similar vulnerabilities to, say, view faxes. So the record IDs are just randomly generated numbers. So if you start putting in different numbers, you could view different faxes. Most of these are fixed now, thankfully. But this is a really big one. Or like another example would be if you're in an application and you're editing a user, say, in the NextOS portal, and in the URL it has /users/ your username. One of the things I do in every application when I log in is I look for stuff like this. And if I see my username there, I try and change it to another username or something generic like admin, and I see what happens. Because there's so many cases where you can just change that and get data back that you really shouldn't be able to get. Secret storage is really critical for an application. One of the things you absolutely should never do is try to implement your own cryptography. It's just a terrible idea. And when you have tools that can do the things you need, you should use those tools. So if you know that there's a package written to do what you need, you should definitely do that. And I think that this is this is really an excellent example because unless you're a cryptographer, you shouldn't be trying to implement your own cryptography because you will absolutely mess things up. So we need to make sure that all of our secrets in all of our applications are stored securely, which means no passwords or API keys committed to Git anywhere unless they're separately encrypted like in an Ansible vault. And the keys to the Ansible vault are not kept in Git, so that there's no way that someone, even with full access to our Git repository, could access that data. We shouldn't store private SSH keys or GPG keys or PGP keys in Git, or server certificates, for example, private server certificates. All of that shouldn't be in Git or should be encrypted and not have the keys to decrypt that data in Git. There's also a huge list here of things we should not log in our applications, including passwords while the app is starting up, and like the passwords to get into key stores. We shouldn't log trace HTTP header trace data in our logs, or if we do, we should make sure that we check for certain headers and either remove them or erase the data that's in them that's important. So like the base64 encoded usernames and passwords that are in the authentication headers, you want to make sure that you just wipe that field out entirely if you're logging it, which you can do in Log4j pretty easily. You can add a filter for that. We have emails that get generated for new users that have usernames and passwords in them. You don't want to log the text of that email if it contains the password, obviously. We never want to log JSON web tokens because they are the authentication data needed for a user to have access to resources. The same with session tokens. We shouldn't log those. If we need some way to identify a session, we can generate a hash from that or something, but we shouldn't use the session ID that's in their cookie to actually identify them, because someone could use that to access the same resources. OAuth tokens, we also should not log. This is a critical one because in a lot of these cases, this gives access to resources outside of our system. So if we were, say, in our calendar service, logging the tokens that we get from customers to access their calendar and Google Drive data, then someone could steal those tokens and access data we don't have control of and we wouldn't have accessed with the tokens that were generated for us. So it's critical that we not have that data logged and that we keep that as restricted as possible, access to that data. So just some best practices. We shouldn't log any secrets that we don't need to use. So if you're going to set up a new system and it needs an API key from another system, let's say these are two different cloud applications. It's easiest just to generate a new API key for the one system, put it in the other system, and not keep a copy of it. If you need it, you can make a new one. It's significantly easier than actually trying to know where you should keep it, how you should keep it, who should have access. It's just much easier not to do that if you don't need it. If you're issuing secrets to users, make sure that you track who has access to them and make sure that you revoke them as needed. So like if you have Salesforce login, but you need to have API access and someone gives you an API user, make sure that we track that API user along with the Salesforce user so that we know when we deactivate the Salesforce user, we need to deactivate the other one. Ensure that when you're issuing tokens to someone, that they have just access to the resources that they need. So generate a new user or API key for every application as best as possible. This is something that we're doing with Oracle more and more, is that all of our applications have their own logins to the database and have different access depending on what they need, which makes a lot of sense. So our own internal services, we have a lot of issues around authenticating too. So we should be securing all of our services with tokens that are kept secret, that are different for different people and different applications, so that we know what we can revoke and what has access to what resources. We currently don't do that, but here's a few things we do and why they're not good. Some of our services, we use the word lab or production plus the name of the service for authentication. This doesn't really provide us any sort of security, because once you see this in one application, you know that every other application is going to work the same way. And now this does prevent someone from doing some sort of attack where they can, say, issue a request inside of our network, but they don't have access to things, because they would still have to have that authentication header in there. But someone inside of our network would have no problem figuring out what that is. For Tyke, we just have one token, I believe, for access to all the different endpoints. We have some applications that some services that don't have any authentication, so you can just call them directly, and yeah, that's not good. And then on JSON Web Tokens, real quick, they're interesting because they're cryptographically signed bundles of information that identify a user. So the server issues the JSON Web Token, and it can validate that token at a later time by checking to see if the cryptographic signatures match. So the server doesn't need to track session data when you do this. But it does mean that whatever data you put in there, you're giving to the end user. So you don't want to keep any secrets in there that the customer wouldn't know. You also want to make sure that, because you can't revoke these, because there's no concept of revoking them, because the end user just has a copy of it, you need to make sure that if someone, say, logs out of the application and they have a JSON Web Token that expires in an hour, that you track all of the tokens for people logging out and then add them to some sort of deny list, so that if someone tries to use that token after logout, they're not authenticated anymore. There's also a very large issue here around secrets, because if you have the private key used to generate the JSON Web Token, you can issue JSON Web Tokens that are valid on behalf of any user without needing to know anything else. You just have the secret needed to generate more tokens. So you really need to keep those super secret, and no one should have access to them. Otherwise, they can act on behalf of any user in the system. Yeah. That's all I have for today.
That's it. Thank you. Thank you, Steven. Does anyone have any questions? You can drop them on the chat or just unmute yourself. Don't be shy. I know there was a lot of information, but very good images. Thank you, Steven.
I'm happy to help anyone figure out any of this in applications as well. So if you see something and you don't know if it makes sense, or if you don't know how to implement something properly, if I don't know, I know where to look to help figure out some of that. But obviously, the more I learn, the better I am at this stuff. So
that's great. We have one from Danielle. It says, is this type of training offered for our new hires? It will be. Yeah, I will be answering that one. But yeah, we are recording this session, so this will be part of our onboarding. So yeah, they will have all of this information. Oh,
Hi,
yeah, we have the Hack Edu. Oh yeah, go ahead. Who's asking?
Hi, this is Bas Becker. Hi, Steve.
Hi.
In my previous job, we had quite strict rules, a process for security scanning, and when you detected like an outside vulnerability that came in, or a customer detected, what very strict rules about fixing those. There was a whole department working on that. Do we have something like that here in this company?
We have a small team that my team that deals with some of that. We do have scanning set up on a lot of these applications, but we don't have, the scanning isn't always acted on in a timely manner, which is something we're trying to solve. But it's something we obviously need to move forward with and towards, so that we have a better, security posture, and we don't just know what the problems are that we have, but we actually fix them. We do have Bug Crowd is set up to accept submissions from third parties. So if anyone submits something to that, we do triage those, and then we make sure that they are fixed quickly. So anyone outside of the company that submits something there, we take action on quickly and make sure that those things are fixed. Does that answer your question?
Yeah.
Yeah, that does answer. Is it documented somewhere, or do we have an entry point where to look or contact you guys?
Like for Bug Crowd, or for anything else?
Yeah, it could be anything. How to use the Veracode tools. If we want to know something about a vulnerability, or
Yeah, I mean, you can contact anyone on my team, or if it's something that you can put into a ticket, we have a service desk that you can submit. We also have a link on our website, I believe, for customers to submit vulnerabilities. Well, they're not usually customers, they're random researchers that scan your websites and then tell you there are things wrong when they're not. And then they submit these things because they expect to get paid. But that's not all of them. That just happens pretty often because there's a industry around submitting vulnerabilities to companies and making money off of it. But we do accept submissions.
Steve, this is Ruth. How would where can they submit tickets to your team? I'm here in our Jira, and I see that service desk, the Nextiva help desk, DevOps, IT, but just so that we can maybe get the link for them.
Yeah.
Or if you can drop the link.
Service desk. See if I know what it is.
I'll put the link in there. It's Portal 25.
Well, there we go.
Thank you, John.
Thank you, John.
Norma, we can just make sure to add this link in the Confluence page once it's ready for everyone to know.
We will.
Right. And if people have general questions, they can email securityoffice@nextiva.com. Right. If you have a problem or other specific question that fits the service desk, you can open tickets there.
Thank you, John. We also have another question from Lance Jeffers. It says there was a lot of talk about keep these things secret and don't push it to Git for those tokens, secret, etc. Where or how do you recommend storing them so that all engineers that need those things can easily retry them?
It depends on a lot of different things. I don't know that we have a good answer to this, which is a problem. But in some of these cases, if we need to share secrets for whatever reason, having them in an Ansible vault makes a lot of sense, and then sharing the key to that vault out of band from Git so that the people that are doing the actual work all have the ability to decrypt the secrets in the Ansible vault. The best way to do this would just be that everyone has their own keys, but I know that that can't work for a lot of things, and our production applications, we need to have, like, the private keys for the certificates, obviously they need to be shared, and other sorts of things like that are our GPG keys we use to encrypt data in our database, they need to be shared. So we really need a better solution for that than what we have now, which I know is not a great answer, but I know that Spring Boot, there's a Spring Cloud configuration component of it that can store configuration data and secrets and stuff like that. Things like tools like that make a lot of sense, and I know that they're working on setting up I forget what it's called now, an application that is for this purpose, to store all the secrets for all the different applications, and then you can generate tokens for the applications, and then just those applications would have access to those applications would just have access to the resources they need. But I don't know that we've actually set that up yet.
Gregory Perry wrote HashiCorp Vault, but I'm not sure if that's what
exactly. Yes.
Oh, awesome. Thank you, Gregory. So just one last question from Miguel says, what options do we have to prevent insecure direct object references?
That's a really tricky one, because these are sort of more policy problems than necessarily security problems. So trying to tell if your access controls are implemented properly or not isn't something that our scanners can do very well. Some of that stuff is sort of done with them, but it's something that you need to test rather than expect that we have a tool that will tell us that that's a problem. So any endpoints that take identifiers that are looked up in other places that may or may not have access, depending on what account they're on or something like that, we need to make sure that we've implemented those sorts of access controls so that we don't grant access to, say, every customer's data rather than just customers on the one account.
Right. But in order to prevent it, you have to make sure that you're checking access authorization tokens on every single endpoint that your server-side application has. And right, we've seen issues with that in the past where people have done the right thing almost everywhere, but missed a couple. And right, we've had to go back or people have found those, and we've had to go back and fix those quickly. So you have to be rigorous about the server-side user authorization on every possible endpoint.
In the fax platform, I wrote an automated test suite using PyTest that has about 1,000 tests in it now that get executed when I run it to check for those types of issues. So every bug that we've had reported and every one that I found, I put into the test suite, and then the suite runs with different levels of access, and it knows which user's data it should not be able to access, and it tries to access them all, and then it reports on which things failed the tests. So this is where QA could really come in and make sure that we have automated tests that not only make sure that endpoints work right, but when you either send unauthorized users to them or when you send invalid data that could be part of some other sort of attack, that those things are rejected automatically. You could write tests for that.
Thank you. And Bas just dropped another one. Do we have any licenses to the scanning dynamic source tools we use in Xtiva?
Yeah, so everything should be scanned by barcode. I don't know who all has users, but I think a lot of people do. We can make sure if you don't have access that you can get access. But as part of our build process in Jenkins, we should be scanning all applications that are built using barcode. And then reports are generated in the barcode portal, and tickets are created in the barcode Jira project, which isn't useful because you probably didn't know it existed, but the plan is to mirror those into the product development tickets when the vulnerabilities are a certain level. So that's on me to finish up.
Nice. Well, this was great. Thank you, Stephen, for doing this. Thanks, John, for also encouraging us to do this. And thank you, everyone, for joining. We will be sharing, as I said, the recording and the presentation on a blog post, hopefully tomorrow or Friday.